Okay, now we're going to do some inference examples for population mean, so confidence intervals, hypothesis testing, discussing errors, how they relate. Okay. A study at a small school found the table below for the hours slept the previous night. The minimum recommended amount of sleep is 7 hours, determine 90% confidence interval, and interpret its meaning, determine alpha. Since the recommended amount of sleep is 7 hours or more, are the students at this school getting a minimum of 7 hours of sleep? Do a hypothesis test to explain your findings. If there's an error, explain what it might be. Explain if and why the confidence interval is in agreement with the hypothesis test. All right, so I took all that data and I put it into a spreadsheet here. So I'm going to add them up. And I'm going to divide by 25 to get the mean. The standard deviation is standard deviation dot sample, because this is obviously not every single kid in the world. Okay. Then we need to do the t star, which would be t dot inverse 0.95, comma. And then we need to do this minus 1 for the degrees of freedom. Okay. So we need to count how many values there are, which in fact there are 25. This is a short list, so we don't really need to do this, but that's how you would do it. Okay. So this is our area and then our degrees of freedom essentially there, correct? Because essentially if you think about it, oops, right? If it's a 90% confidence interval, right, and then alpha is 10, then each of these is a half alpha. So from here to here is 95 essentially, right? That plus that's 95. So t25 minus 1 should give us negative 0.71 and positive 0.71 to get to those n values, basically. Okay, so which is what we got. Okay. 7.1, that's what we got. Okay, so the standard error is the standard deviation divided by the square root of the value of n, right? Correct, which is this piece right here. And if I times it by t, this whole piece, right, this whole piece here is the margin of error, right? So t times the standard error is the margin of error. Okay, so our confidence interval is the sample minus the margin of error, and the sample plus the margin of error. Okay, so that is the number of hours and the number of hours essentially, correct? Okay, so we can copy, go back to here, and we can give you the full answer. So essentially, we did the confidence interval on the spreadsheet, and this is what we got for t25 minus 1 degrees of freedom with 25 samples. We believe the actual number of hours to be in there for the number of kids, the hours that kids are sleeping at this particular school. Okay, with an alpha of 0.010. So pictorially, what are we looking at? So, right, at t0, that's our sample, 6.64 hours for those kids that we had. So we feel that our actual interval is between here and with 90% confidence, essentially. And our tails are half alpha, which is 5% each, essentially. Okay, let's do the hypothesis test now. So now we're not doing mean proportion anymore. We're doing mean, right? So now we're doing a mean for the hours of sleep for the kids, and this is a one sample t-test because this is mean, so we have to do t-test, and we're checking to see if it's less than 7 hours, because technically this is greater than or equal to, right? Because if everything's okay, it's greater. We just assume it's greater than or equal to 7 numbers of hours, but we're trying to prove otherwise, so we're trying to prove less. But for the sake of stats 1, we're going to keep them as less than. Okay, so for step 2, can we actually do it? So we can't do the n times p, n times q rule. This is not a proportion. So essentially, we just assume that they're independent because you're not likely to take this twice. And if you try to graph it using Excel, you'll find that it's approximately unimodal or normal. Okay, so we get these things in the computer. So the sample mean is 7, and the sample deviation is, or standard error is this essentially, which we did in the actual spreadsheet. Now we get to do step 3, which is actually do it. So we're going to do the t-stat, which is the sample minus the population divided by the standard error, correct? Standard error. Okay, so that's our t-value, which is a negative t-value. Okay, so that means if we want to figure out the area, okay, it's going to be this area over here. So I don't need to do a 1 minus or anything else essentially. Okay, all right, so t dot distribution, right, we're going to click on that, minus the degrees of freedom, which is n minus 1, and true. So that is our area, which is also the p-value. Okay. So go back to our notes, and we're going to put step 3 and put that down. So we're going to make that blue, and we'll make that bold and italic. We don't need to underline. Okay, so that's what we got there, 1.67, right? 1.67 for the t-stat, and we got this area here, which looks like that area is in fact greater than alpha, right? So we'll do step 4. Step 4, the p-value is clearly bigger than alpha. Okay, so we do not reject, so our sample mean is not significant and likely to occur. There is not enough evidence to reject the null hypothesis. It is likely that the students are getting at least 7 hours of sleep at this small school, right? Because we're trying to prove they got less. We didn't prove it though, right? There was not enough evidence. So the confidence interval and the hypothesis test are in agreement because we did not reject the null hypothesis, and the 7 hours was in the confidence interval, right? So we didn't reject, which means it's a common sample, right? And the 7 is clearly in that confidence interval there, right? Okay, so the last thing is, if there is an error, it would be a type 2 error because we did not reject the null hypothesis when it might be false. There is a high likelihood because the p-value is very close to alpha, and the 7 hours is just inside the interval. Okay, so very high likelihood of a type 2, but what are you going to do here? So looking at the pictures that I've drawn here, let me just make this bigger. Shoot. That is not what I want to do. It's close to alpha, and 7 hours is just inside the interval. Okay, let's try not to screw this up anymore. Okay, so the confidence interval T0, 6.64 is the sample, and the hypothesis test T0 is 7 hours. Okay, so we have the same T critical, right, except it's only a one tail for the hypothesis test, and the hypothesis test, the alpha is 0.05 because it's only one tail. And the alpha for the confidence interval is 0.10, right? Because it's a 90% confidence, so 10%, there's two tails. Okay, so the t-stat is clearly not inside the critical region. This is the critical region. This is the t-critical, right? It didn't make it there. Therefore, the area is more because it's on the outside. It didn't make it there. So it's in the region of expected samples. So we did not find enough evidence. So this is finding enough evidence over here. We did not find enough evidence, essentially, to conclude the null hypothesis is false.